Former Secretary of Department of Energy, serving during President Obama's second term, and Emeritus Professor of Physics at the MIT, Ernest Moniz, what are the main challenges that science and technological development must face today in the energetic sector?
Well, first of all, I believe the key to managing our challenges in clean energy and climate change, in fact, lies with science and engineering. It's innovation that ultimately, I believe, will lead policy to manage the risks that we see from a warming planet. Now, the science challenges themselves are extremely broad. Of course, we all know that energy efficiency technologies and clean electricity generating technologies are certainly essential. We cannot meet our goals without success in those areas. But in electricity, there are many technologies. There's advanced solar technologies, advanced nuclear technologies. Very importantly, we've made little progress, in my view, on carbon capture as a technology for low-carbon electricity. But what I want to emphasize is that in addition to solving those particular technology problems, we also need to solve systems problems. For example, the electricity sector really calls for a complete integration with information technology. We're in the very early stages of doing that. And then beyond electricity, we have even greater challenges in transportation and industry. If you think about it, industry is not going to become completely electrified. We have to be able to manage processes that make steel, that make petrochemicals, etc. A lot of innovation is required there. And in fact, I believe we have to complement this with what's often called large-scale carbon management. For example, can we find a way of using carbon dioxide on an enormous scale to keep it out of the atmosphere? Can we use biology to change how the land sequesters carbon dioxide? So it's a very, very broad set of challenges. We need to follow these aggressively. We will not manage to meet our goals without success from scientists and engineers in innovation.
You are a scientist and a politician, and climate science is an international collaborative effort, and finding a solution to climate change must take form in an internationally coordinated effort. Is there something that politics could learn from science in this regard, also in the light of President Trump's decision to pull out of Paris Agreement?
Well, science certainly has to become more core to our governance and to our diplomacy. Actually, in a different realm, I would say that my own experience in negotiating the Iran agreement, for example, was one where adding scientists to the negotiating team with the foreign ministers was absolutely essential in doing that. Clearly, climate is another area that is very deep in science, and so having scientists more engaged in governance is essential. If I take the United States, our Congress has 535 members. One of them is a PhD scientist. We need more students, more faculty getting interested and being willing to spend their time bringing science to governance so that we can have more informed decisions.
By polluting our environment, we damage future generations. Is it possible to introduce a concept like future generation rights in the public debate?
Well, I think concern for future generations, of course, is very much internalized by those of us who are committed to addressing climate change. The problem is, honestly, while I think most parents, for sure, understand completely the importance of preserving the environment for their children, for their grandchildren, the reality is many of them have other concerns as well, like feeding them tomorrow, etc., getting them to school, having good jobs, etc. So the reality is that climate change does present a challenge, as we know, because the impacts are not immediately visible. They only occur on a generational timescale, and yet, most citizens have concerns that are much more urgent. So we need to keep the education going. We need for educated citizens in the end to recognize that this transition to a clean energy future is possible. It is possible to do it with the economy strong, and they need to pressure their elected officials, in fact, to carry through with the policies so that their children and grandchildren will be cared for.
So the ideal goal is a clean energy future, but of course our production system is still highly dependent from fossil fuels. How will the job market be affected by the transition to a clean energy future?
Well, first of all, we should recognize that the job market in Italy, in the United States, and many other countries, of course, is already undergoing a lot of disruption, not just because of clean energy, but because of all the other technology developments that we see, artificial intelligence and IT and robotics, automation. There's new ways of manufacturing. The reality is the key in this context, in this age of rapid technology change, ultimately is an educated workforce that has the ability to manage these technologies and to adapt. So that's critical. Now, when we go to energy specifically, clearly fossil fuels will continue to be with us for a while. And in fact, some of the technologies we need to develop are ways of using fossil fuels without carbon emissions. And that's where we need, I think, a much bigger effort. So there's no doubt there will be change, but what we are working on is certainly to try to do a bottom-up approach with families and communities so that they can understand what it takes for them to be part of a strong economy with very, very low carbon emissions.
Some North European countries are doing pretty well in producing electricity from renewable sources. Is it something that can be extended in principle to all countries, or is it just a prerogative of relatively small countries?
Well, first of all, I think renewable resources are certainly present just about anywhere. They may have different weights, whether it's wind or solar or geothermal or hydropower, for example. But big countries, of course, are part of this. Actually, I should say that in the United States, we have reduced our carbon emissions by about 12% since 2005, and that has two major pieces. Actually, three major pieces. One is we have become a more efficient economy in terms of energy use. Secondly, our natural gas production has had an enormous impact. Over half of the reduction in carbon dioxide emissions that we have experienced has come through market forces that sees the utilities preferring natural gas to coal. And when natural gas replaces coal, that reduces the carbon emissions quite substantially. And then third, we are seeing a significant increase in wind and sun. Our wind and sun capacity is now over 100,000 megawatts. So it's really quite substantial and still growing. So I think in the end, the low carbon solutions are going to look different in different countries. They're going to look different in different parts of my own country because the renewable resources are different, the fossil resources are different, the opportunities for burying carbon dioxide are different. And so I think what's important is in innovation, we have to pursue all the options so that they are available to different communities, different states, different regions, different countries to use in their own way to meet low carbon goals.
What is the role that nuclear energy, along with renewable sources, might play in a clean energy future?
I might say that in the United States, I should have said in our mix, nuclear energy is still quite a major contributor. We have the largest nuclear fleet in the world, almost 100 nuclear reactors are operating, and they have contributed more than half of our carbon-free energy. So they are a very important low-carbon source. Now, of course, they are challenged. In the United States, I mentioned natural gas displacing coal. Natural gas is also displacing some nuclear power. Several plants now are closing down because of the economic competition. So in general, especially in the developed countries, I think nuclear power has a big challenge of keeping costs under control in construction. Their operating costs are very low, but the construction costs in Europe and in the United States, in both cases, have been much more than was budgeted. There are some new technologies. For example, just to give an example, in the United States and in some European countries, there is a strong push towards what are called small modular reactors. The idea is, rather than going to nuclear reactors beyond 1,000 megawatts, let's instead go to 50 megawatts or 100 megawatts. And that can change the game very dramatically in terms of how you build them economically, how you finance them. And so this is an example of a direction that could be a major one for nuclear energy remaining part of our zero carbon energy supply.